Welcome to Summer Math Mashup, where we will be exploring fun math challenges for families to enjoy together. Summer Math Mashup is a collaborative effort between the Department of Mathematics at Iowa State University and the North Central region of the Governor's STEM Advisory Council.
Hello and welcome to this week's Summer Math Mashup video. My name is Abigail, and today we're going to be learning about one of my absolute favorite subjects, mathematical knots. I love mathematical knots because they're an excuse to learn about geometry and think about shapes and position and three-dimensional objects without worrying about things like measuring angles and drawing straight lines. A little bit about me. I am a post-bachelor student here at Iowa State University, and pretty soon I will be starting my master's degree studying exactly this, knots, and what we will come to know as the subject of topology. For this activity, you're going to need two pieces of string, about a foot or two long. You don't want it to be too long because then it'll be hard to work with. I picked two different colors, a green and a purple string, and you'll also need some tape. I've got clear tape here, but masking tape would work just as well. So let's get started. The big overarching topic that we're working in today is called topology. Throughout the ages, this area of math research has been known as the geometry of position, or by me as squishy geometry. And what that basically means is that topology studies how much we can manipulate objects without having to poke holes or add on pieces. So for example, a donut that is round and has a round hole in the middle would be considered the same or isomorphic to a donut that was made in the shape of a square with a square hole. But a donut with a hole in the middle would be considered different to a donut that didn't have a hole through the center, because I'd have to poke a hole through it and break things in order to get from one shape to the other. So that's what we're going to be doing today, is moving between shapes and seeing how much we can do that movement without having to break anything. Knots are a really good candidate for studying using the lens of topology because they are so flexible, right? When you think about a knot, you probably think about what you do to tie your shoelaces. You take your piece of string, twist it, make that loop, maybe make some bunny ears, and there you go, a shoelace knot. But to a mathematician, this isn't quite all that you need to do. In order for this to be a proper mathematical knot, we now need to take the ends of that string and glue them together so that the resulting shape can't come undone. This is where your piece of tape comes in. And now I have a mathematical knot. I have a circle of string that's been all sorts of tangled up, and I can ask lots of questions about it. So here's what I'd like you to do. Take your piece of string and tangle it up. It doesn't have to be just like a shoelace. It can be any sort of twisting or tangling or looping about, anything except for cutting the string. Do whatever you want, but don't make it too tight because we're going to need to play with it a little bit more. And once you have that, take a piece of tape and tape your ends together. You can pause the video now to get yourself a tangle that you're happy with. Now that you have your knot, we have to ask some questions about it. The biggest question that we ask when we are working with a mathematical knot is how many crossings does it have? And a crossing is wherever the string that you have crosses over top of or underneath of another piece of the string. So I can use mine as an example here. Starting from the bottom, I see 1, 2, 3, 4, 5, 6, 7 crossings. So my knot is a knot with 7 crossings. And now that I know that, I'd like to ask if there's a way that I can possibly untangle it. So can I make it so that there are fewer crossings in my knot by moving the string around? Now remember, we aren't allowed to break the loop that we created, so you can't take off that piece of tape. But you can move the string around however you want, so long as you don't do that. So for example, I see right down here, my string crosses behind itself twice. And so I'm just going to pull that loop right out of there. And now I've gotten rid of redo the move. I've gotten rid of 1, 2, 3, 4 crossings by removing that loop. So now I have a knot with only 3 crossings on it. Okay, well, if we can untangle it and make it simpler, maybe we can untangle it so much that it's not even a knot at all. So take, for example, this little diagram here. If I were to pull the string out so that this piece right here, so that it wasn't over top anymore, I could untwist what remained, and I would be left with just this circular piece of string with no crossings at all. And in fact, the same thing happens to my little knot here. I've undone that loop. Now I can stretch it out, untwist it, and I've created a plain circle. This is called an unknot. And this is what happens if you've accidentally created a tangle that isn't knotted on itself at all. There are lots of other questions we can ask too about things called invariants. An invariant is any property of a knot that doesn't change no matter how much you tangle it up or untangle it, so long as you don't cut the string. Take a few minutes, try to answer these questions about the knot that you've created, and maybe ask some more of your own too. Feel free to pause the video here, but in the meanwhile, I'm going to go on an adventure. The next thing we're going to talk about is an invariant called chirality. And chirality asks the question, is this knot the same as its mirror image? So if we were to flip all of the places where the string goes over and under, do we still have the same knot? In other words, can we move from one to the other without breaking our string? And to do this, you're going to need to have both of your pieces of string, and you're going to want to take the tape off the ends so that you can make a new knot. This will be a lot easier for you to do against a table or another hard surface, but I'll do it like this so that you can see. So start with one end of your string at the top, so either hold it up like this or put it at the top of your paper. And you're going to swoop down and then swoop back up so that you've almost got a loop. And you're going to let the free end, the one that you didn't place at the top of your surface right at the beginning, you're going to take that one and you're going to pass it in front. So you've got one end sticking up and the other end coming in front of that end. Now when you bring it around, you're going to go behind it. So I'm going to take my string, pass it in front, and then loop it behind. And then lastly, we're going to pull it in front. So this is a lot like the beginning of tying your shoes, except we're interested in kind of creating a shape here. So once you've got that, so you've gone in front, behind, and in front, go ahead and tape those ends together. Now with your other string, and I'm going to use a different color here, I've moved from purple to green here. Start at the top again. And this time when you bring that free end around, you're going to go behind first. So behind, and then in front, and then you guessed it, behind. Oop. Like I said, this is going to be a lot easier for you to do on a surface. All right, so now what you should have are two knots with 3 crossings each. So count them, 1, 2, 3, and 1, 2, 3. And they should be mirror images of each other. So if you lay them out on the table, you should be able to see that wherever one goes in front, the other goes behind. And so I'd like you to sit here for a minute, maybe pause the video, and play with it a little bit and see if you can get from one to the other without ever breaking that tape. Go ahead and do that now. Hopefully by now you've had an opportunity to mess around with this a little bit, and maybe you're feeling a little bit frustrated because it turns out that this knot is in fact chiral. That means there is no way to move from one of those knots that we tied to the other without taking off the tape or cutting the string in some sort of way. This is kind of weird because 3 is the smallest number of crossings that any of our knots can have before they're just a twisted circle, or what we called before the unknot. So it's kind of funky that the simplest possible knot is not equivalent to its own mirror image. Let's try this experiment again, but with a more complicated knot. This knot is called the figure 8 knot, and it will have 4 crossings. So once again, you'll want your strings, and you'll want them to be loose, so take that tape off, and stick one end at the top. Once you've done that, you're going to bring the end up behind, just like before, only instead of behind, you're going to want to cross in front right at the beginning here. So I just took my string, crossed it in front of itself. Once you've done that, you're going to come around to the side, and you're actually going to pass in front again. So now I've passed in front of my top piece, and now I'm passing in front again. Now here's where we're going to put that knottedness, that tangle in. Take your string and cross it behind. So pass behind that very first strand in the middle of the circle that you've created, and then come up in front of the big giant loop that was created when you looped around the first time. So the result is that you will have, when you put the ends together, a sort of figure 8 shape in the middle. That's why it's called the figure 8 knot, with this big circle passing through it. So when you have that, and when you're satisfied that it's tangled up, you can tape the ends together. And there's your first figure 8 knot. Let's do it again, but backward. So take your other piece of string, take that very top piece and put it right at the front, and bring your loop around, this time passing behind. Which means that because we're doing everything exactly opposite of what we did the first time, we're going to pass behind again. And once we're in the middle of that big circle, pass in front of the piece that's sticking up, and then pass behind the big circular piece. And feel free to replay the segment if that wasn't totally clear the first time. The result should be a knot with 4 crossings and that same figure 8 shape in the middle, just facing the opposite direction from what you originally made. Once you have both of your figure 8 knots, you have the same job as before. See if you can get from one to the other without cutting your string or taking off that tape. I'll give you some time to do that. In the meanwhile, I'll keep myself busy. One more thing that I'd like to share with you is what mathematicians call knot diagrams. So today I've drawn these simple line drawings on the whiteboard to show you what the knots are that we're working with. And in mathematics, we use these drawings to help us decipher whether 2 knots are the same or different, or what it looks like when we change those crossings without having to use an actual piece of string. Another way to represent knots is with a piece of string like we've been doing today. But those aren't our only 2 options. If you have pipe cleaners lying around, you can make your knot and then twist it into a more rigid shape to create a sculptural knot, which can be really interesting. Here's one that I made of a knot with 10 crossings. And you'll notice that it's okay for me to have this little curlicue on the side because that doesn't actually change anything about the knot. It doesn't add or subtract any crossings. So it's okay to represent my knot in a fun and interesting way, just like this. I also like to make knot sculptures out of beads. Here's one that I made of one of those knots with 3 crossings that we made earlier. And here's an example with 4. Knots can get much more elaborate than this. And you may have noticed this when you made your own knot in your time earlier. You can have a knot with say 5 crossings, or 6 crossings, or maybe as many as 10. When we do this, sometimes we get these really cool symmetrical shapes, just like this knot, and sometimes you might notice some interesting forms in them. So for example, I think this knot with 6 crossings looks like a little stick figure going on a walk. It can be a lot of fun to draw knot diagrams, make little knotted sculptures, and play around with these ideas as both an exercise in topology, but also as an exercise in art. As always, we encourage you to explore this activity and knots in general as a family. The goal of this series is to make math fun, engaging, and accessible for everybody this summer. Make sure that you check back next week for the latest Summer Math Mashup video, and thank you so much for watching and tying knots with me today. Have a wonderful rest of your summer.
Thank you for joining us this week. We encourage you to explore this activity as a family. Our goal is to empower families and kids in math by making math accessible and engaging. We want to thank all the students in the Department of Mathematics who made this event possible. Learn more about upcoming STEM events and opportunities at www.ncstemhub.iastate.edu.